And welcome to Tidyx. My name is Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center in Seattle, Washington. So Tidyx is a screencast where we're trying to get more people involved in Tidy Tuesday. So what we do is we do a code review of Tidy Tuesday submissions to help people understand what's going on with the plots that they're seeing on their Twitter feeds and make it more accessible for everybody. And additionally, we'll also be going through and showing how the same plots can also be used for additional data sets to show once how you learn something, you can then apply that to additional data sets. And the goal also is to inspire more people to just be involved with hashtag Tidy Tuesday. Right now we're showing the website for Tidy Tuesday. It's on GitHub through the R for Data Science. They post a weekly data set where people get on and start visualizing and analyzing the data set and share it on Twitter using the hashtag Tidy Tuesday. With me today is Patrick Ward.
Thanks. I'm here with Ellis today, and I work for the Seattle Seahawks doing research and development. I got involved in Tidy Tuesday after Ellis prompted me to do so. We found that actually you did a Twitter poll where you were trying to figure out why people would or would not get involved. Some of the people, it was time, which was my case. But then I kind of went back, and in my blog, I actually did a write-up of an older data set from, I think it's like November 2019 on powerlifting, and so I kind of made a little contribution there. And then we also found that there was a lot of people who said they didn't get involved because they were nervous about where to start, which I think was kind of the goal to get this off the ground.
So Tidy Tuesday, the whole point of Tidy Tuesday is give people an opportunity to practice their skills. Some people are really advanced and really generate some wonderful and amazing plots here, but you don't have to be at that level necessarily in order to participate. Anything you make, you can throw into Tidy Tuesday, and people give you feedback with that data set. So with that being said, we're going to get going on this first post that we saw. So this is from week 4 of 2020. So this is data that was posted of San Francisco trees. And so in this episode, we're going to be going through Courtney Gerver. Sorry if I said your name incorrectly. Her submission where she created a tree plot of the number of species of trees per year. She also very kindly included a link to her code, which is how we found and are going through what she submitted. And so we took this code and we've copied that into our RStudio session that we have going on here. And we will go through this and provide feedback on what she's doing, as well as provide information, potentially feedback on what could be improved.
Okay. So why don't we start from the top? I'm actually going to go ahead and load the Tidyverse package right from the top. So for those that don't know, Tidyverse is a suite of packages which offer lots of different things in terms of data pre-processing, data visualization. So it'll automatically load packages that you might normally load individually, like ggplot2, dplyr, stringer, and you can see here in Courtney's code, she actually loaded each of these packages independently. I just commented them out because I'm going to go ahead and just load Tidyverse right at the top, since it's going to automatically do that for us.
And that's definitely a way to do it. There's definitely a preference towards having your libraries loaded at the very beginning. For people that are reviewing your code, it makes it a lot easier to see what libraries are going to be needing as they go through your code to understand it. But that's definitely a style preference. Then after she loads, so the first step that she does here is she also then loads in the SF trees data set from Tidy Tuesday. So here she uses readr to load reads and uses read_CSV and then initially views it. Alternatively, there's a package that I developed called Tidy Tuesday R, which is available on GitHub, where you only have to feed in the year and the week number, and it'll load all that information in there for you. But this is definitely a good way to go, and it's the common way a lot of people do it.
Now, before we just take a look at the data set here, one thing that I would like to bring up is she does a really cool job of commenting out the different subsets of her her post here. So it's really useful for someone who's trying to go through and evaluate this. They can see really quickly where she loads the data, if there was any pre-processing steps, where she kind of explores the data. Here's a bit more pre-processing. We'll go through what she did there. And then when she finally visualizes this, it's almost like a setup of an R Markdown file within an R script.
And for those of you that don't know R Markdown is a way to combine prose, so normal text, with your code itself. And so you use a thing called chunks to define what you're writing in code. So there's just two different ways to approach data sets or data processing, and both definitely work fine. All right.
So we'll go ahead and we'll take a look at the data that we've loaded in. We'll open it up here in a little view window so we can see each tree. Some legal status information. We see the species of the tree. We'll notice here, because this is important, it's a step that she actually does. It looks like the species is then followed by these two little semicolons and then the type of tree. We see some information about the site order, the site info.
When it was planted. The location.
Yep. And then, latitude and longitude location. Okay, so we've seen the data set a little bit. We'll go down here again. She had originally just loaded string R. I commented that out because it originally comes with Tidyverse if you load it all together. So we'll talk through here a bit of the pre-processing steps that she went through. Why don't we start here with line 1 or line 21, I guess.
All right, so as you can see here, she's nested a few of these functions, but what she's doing is she's extracting the species field from SF trees and calls a function called word, which I actually hadn't heard of before.
Yeah, neither of us had actually. When we were going through this, we were like, oh, I wonder what that function does. For those that don't know, if you're ever not knowing what a function is, you can always type question mark and then the function name. And you get a handy little helper over here. So it looks like word is coming from the string R package and extracts words from a sentence.
Oh, wow. Well, it does exactly what you said.
There you go.
It does.
Okay.
All right. So she's extracting. If you look at that, she didn't name the arguments, but out of the species field, she's extracting from 1 to 2. So that would be the first 2 words that she's extracting out of
so
that.
If we go back here, right, there'd be 2 words, 1 word.
And so it probably has error handling underneath the hood.
I'm not sure what it would do in those situations because I've never used that function. You could have used, and we'll show it in our follow-up example, something like the separate function and pipe this together all into one single argument. But this is fine for right now. We'll just run this. And we've got now a data frame that she created with the species type. So I can actually go down here and look at what it is that just happened. So there it is. She didn't assign a name to the expression that she gave here, so it kind of gave the entire expression automatically as the name, which is what the next step is she just then gives that first column the name species. So we did that.
All right, so now she has this data set of all the species of all the trees, but now she uses cbind to combine it into her larger data set. So this is a way to be combining 2 different data frames into a single data frame. This also then you have to make the assumption that the same rows are in the same order, which is fine because she hasn't done any manipulations to it.
Right.
All right, so that gets run. So now you'll see in SF trees that we have a new field called species, or species A.
And there it is.
There we go. All right, so then now she has this data set, SF trees, and...
So it looks like that word function kept it recognized, I guess, the next element in that vector as like as a word, so it kept the semicolons.
Yeah. So now she's going to go through and use gsub, which I forget what it actually stands for. What it does is you feed a pattern into it as the first argument as to what it should be searching for. And then the second argument tells it what it should be replacing when it finds that pattern, what it should be replacing it with. So what she's doing here is she finds any punctuations and replaces that with an empty space.
And she does it in the data frame SF trees on the column species. So we'll go ahead and we'll run that. Okay.
That runs through and that generates, it just replaces that. So we won't look into that anymore.
Yep.
All right. So now she's going through and she wants to identify what year the trees are planted.
Yeah.
And
so we see in the date column, we have year, month, and day. Mm-hmm. And so she uses the substring function to take that date column and she passes it a start 1 and a stop 4. So it's basically going to count 1, 2, 3, 4 and deposit those 4 values into this column that she's named year.
And this works because we know that the date has the same format, right? So each of the date records starts with year, and it's the 4 numbers that make up the year. It's not abbreviated or anything like that. So that's lucky to have there.
And then the final step that she does before going to make this cool plot is she just basically selects out the last 4 years, probably because if you look back at the data, it looks like it does go back quite a bit. So probably for plotting purposes, to make it nice, just keep it recent, right?
Yeah, reduce the number of records, improve the quality of it by reducing the amount of data that's going into it.
So now we're ready. You can see that she's moved to the plot section of her script, which is nice again and labeled out. Again, I've commented out dplyr because it is loaded with Tidyverse. And here she creates a data frame called count using the count function. So I'd probably, you do a lot of data cleanup. I'd probably call it something like species count or something like that, just because count is the name of an actual function.
Mm-hmm. Giving objects a really representative name helps you when you come back to it really understand what you were doing. So she's going through grouping by species and year and generating a count for this. So this generates a data frame. So let's run that.
Yep.
This generates a data frame where it's species, year, and the number of records that fall under that category.
Correct.
So we took a head of here, and this is just the top 6 records, but this data set is fairly large.
Yeah.
As you can see in the next step here, where she's actually removing a few rows.
Yeah, so there were some empty rows, which I think were due to the issues of columns or rows like this, where there was trees, semicolon, and then it looked like whoever planted these trees forgot to record maybe the species that it was or something like that. And these kinds of errors are common in data sets. So she went ahead and she just removed those rows that came up as NAs. This is okay to do. She's explicitly calling out the rows that she wants to move with the little negative sign here. Mm-hmm. This could have been done within Tidyverse or just using some sort of like filter with, not NA, which might be more useful because if you were to then rerun this script and say go back and pick everything from 2000 to 2019, you're now removing rows that are in the middle because I believe in count, all the NAs are going to get dumped at the bottom. So it's just something to be aware of if you were going to rerun this on extra years. But we'll go ahead and run it here, and that'll get rid of the NAs. So now we have the data frame in a position where we're ready to plot it. And she went ahead and she built a tree map, which was kind of cool because I've never built a tree map before.
Neither have I.
Yeah, so that's one of the reasons why we picked it. So she used the Treemap library, which gives us a Treemap function. Mm-hmm. And you can see here she calls the data frame count, which is the data frame that we just made down there. The index, year, and species are going to tell us what exactly we're plotting on the plot. When I run it here in a second, you'll see what it looks like. And then the V size is the actual size of the square tiles that are coming up in the plot. So we'll go ahead and we'll run this cool looking plot. And you'll see something weird happens here with the viewer.
It's just taking a little bit to run because, as I said, there's a fair amount of data that's going into it. It's because it got assigned to Treemap, and then there we go. So
not really helpful in the viewer here. You'll see in our second example in a second that I just run this out to like a PNG file. You could print it out to a PDF or SVG if you wanted to make it some sort of URL or something like that. Right. We'll go back to her Twitter post so we can look more specifically at the thing here. Image. Yeah, the image. There you go. So you can see it's A pretty cool way to sort of visualize data in like an exploratory data analysis phase.
You can quickly see, if you look in the upper left corner, that is the largest N, so the most number of records that are going to exist for that. Right. So like in 2015, you can see the most planted was the Magnolia grandiflora. But if you move down to 2016, it was a different plant or tree that was planted regularly, and the Magnolia dropped down to be what looks like the third largest. I mean, we're just looking at sizes, so we don't have actual numbers in this situation. But when you don't need numbers for this, because here we're just looking for patterns.
Right. And some of this might be really useful if you say you were doing data analysis for a domain expert, like maybe some biologists or people working in San Francisco that oversee the plotting of such things. You might notice that one that was the highest in 2015, Magnolia grandiflora, was the highest again in 2016, 2017. It's one of the higher ones again in 2018. And then in 2019, it kind of drops down a little bit. So we might be able to plot this type of tree over time and see, maybe these trees grew really well over the past 4 years and they didn't feel the need to to plant as many in 2019.
Or they're working in a different area. There could be, as this data is really rich.
Exactly, yeah.
You could mine this and go through this and find a bunch of different patterns and different really interesting ways that things are interacting and what type of tree is planted, which as a biologist I'm sure is very interesting.
Right, like ginkgo biloba here. Look at that. It's planted. It's relatively large, and then it's totally.
Like we don't see that in 2019.
It's not even planted anymore. So
really
interesting.
Yeah.
Yeah. Pretty cool.
Thank you for sharing this, Courtney. We really appreciate it. And I'm hoping that this is helpful to a lot of people. Now we're going to take our own data and see about generating our own tree plot, because we think we could come up with really cool ways to be using this. So
So kind of piggybacking off of Courtney's observations there, I decided to go through and do something that may be a little bit more top of the mind here. Obviously, the NFL Combine's just finishing up, and the draft will be coming up in a second. So what I did was I went here to Pro Football Reference, and they keep records of all the Combine results on a table like this. So, you can go back through all the seasons, as many seasons as you want, or as many seasons as they have data for. And this information keeps things like the players and the position, the school, college, all of the measurables that took place at the Combine, and then information about their draft position or their draft status. So I went through and I load the RVest package, and I'm just going to scrape that table. So RVest is a really useful package for scraping kind of simple tables like that from the web. I'm just going to scrape that table, and we'll take a look here at the first 4 rows. So there's all the same information that we had before: the player, the position, school, college, measurable data, and then the draft information.
So the draft information, as you can see, is concatenated together. It's got several different bits of information that exist all in one field. Yeah. And that happens fairly often when you're dealing with data. People will be combining, going, oh, they probably want all this information and aren't really sure where to put it. So they drop it into a single field, which is a thing that you have to deal with regularly. Courtney dealt with it in one way. We're going to show another way to handle that.
Yeah. Before we do that, just for more simple kind of plotting purposes, I'm going to just create a larger or more broad positional grouping. So, for example, any player that was a tackle, guard, or center, I'm just going to call them an offensive lineman. Linebackers, I'm going to bunch together the inside and outside linebackers, etc., the defensive back positions, and then edge rushers and defensive ends we'll group together, as well as D tackles will be called defensive linemen. I did this with a bunch of if-else statements. This could have been done with case-when.
Case-whens are an easy way to describe, so you don't have to nest a bunch of if-elses. You can declare your requirements. So you could say position is equal to offensive tackle, offensive guard, or center, and then do a little tilde, which is the squiggle mark that most people are relatively familiar with, and then do the quotes around the OL. And so that'll tell it when it goes through each line, it'll go, okay, if it's a position of OT, OG, or center, assign it the value OL. Yeah, and it makes it really simple for other people to come through and look at your code, so they don't have to figure out your logic there's less logic to figure out, at least, because with the if-else's, you have to understand that when it doesn't hit this, then it goes over to here.
Perfect.
And then we also have at the final there the as character pause for position, because there are some that, like quarterback, that we didn't have to go through. There's not several different positions that are defined as that.
So it's just going to write in for quarterback. If it doesn't see any of these positions in the if else statements, it's just going to drop it in, like quarterback, wide receiver, it'll give it a WR, tight end, a TE, etc. Okay, so here's where we go ahead and we handle that column that we see right here. So Jonathan Abram from Mississippi State, and bunched together here, he was drafted by the Oakland Raiders. That was the draft team. You can see the dots. That's just because in the original data set there's spaces and the parentheses. So he was drafted by the Oakland Raider. He's first round, the 27th pick of the 2019 draft. So I'm going to go ahead and I'm going to separate that column out using the separate function. So up front I call the 2019 combine data set that I scraped from Pro Football Reference, and I pipe that together with the separate function. And this is the column I'll be using, so it's that draft team round year column. And I'm going to separate this into 4 distinct columns. I want a column that gives me the team. I want a column that gives me the round. I want a column that gives me the pick number, and I want a column that gives me the year that they were drafted. And I'm separating that data on these little slashes. And then I pipe one more thing in here. I call a mutate function, which basically says add another column to my data set. I'm going to create a column called round, where I actually will substring out the first 2 characters. So what you'll see here in round is things like first, second, third. So I just want to get rid of those. I just want it to be a numeric value to start. And then I actually turn it into a character and then a factor by saying anytime there's an NA in the round, call him a free agent. And so you'll see here Jonathan Abram was drafted, but the next 4 guys were actually undrafted players, like Nasir Adderley, a safety, went undrafted from Delaware. So he has a blank data in this column from Pro Football Reference. So when I spin this out into these 4 columns, he gets NAs across all 4. So anytime it sees an NA in round, I'm just going to say call him a free agent.
And the assumption is that if they're good enough to get to the combine, they're probably good enough to become a free agent.
So we have that. I did run this into anytime there was an NA, I put it as a F. Actually, I didn't even need to do that. I did it up here, but I redid it. Redid my steps.
That's what happens when you do code review. Right?
Code review myself. I turned this into a factor. I had turned it into a character up here. You can explain a little bit why we might want to turn it into a factor.
A factor allows you to order things that, while the order actually really doesn't matter that much, they should all be seen as a similar order. But then you can use factors to then tell later plotting what order in which you want them to be plotted. So that's useful. I mean, factors are useful when you're doing statistics, which I don't do much of. But if you're doing plotting, it's really useful if you have a character value, but you want it to show up in a specific order in your plots. You can use factors to then turn it into a factor and then define the order in which the levels should be appearing. And then most plotting tools will respect that and plot that in the same order that you define it as.
Correct. So now we've kind of pre-processed the data. We've got it in a position where we want. I'm going to go ahead and I'm going to create a draft count table. So similar to Courtney's tree table, I'm going to count the position groups and the round that they're drafted by. So when I run this, what we'll see is a table that looks like this. And it's going to look similar to the one we saw in Courtney's example. So for example, defensive backs in round 1, there was 3 of them that were taken. This is basically, the count function is basically a really easy way to create a table in a long data frame format. So I could have looked at it like this, something like Combine 2019, and let's say I want my on the vertical, the left axis there. I want maybe something like draft round.
So that's probably towards the end there.
Round, there it is. And then I want to look at this by position, right? So I can run something like this, and it's going to give me this table, which is somewhat useful, I guess, to look at. But I guess not really helpful if you're going to try and plot things.
If you're going to try to use
do
it
analysis
afterwards,
or
you have
exactly.
to throw it into a data frame.
Yeah.
So you can call data frame around that, and it'll turn it into a data frame, but it's usually not very nice to deal with. Count makes it really simple to generate the same data,
right?
But immediately it's tidy.
Correct. Okay. So we have that count data. So now I'm ready to run my tree map. So I'm going to run it on the draft count data, the index. So remember, that's going to be specific to what gets plotted in the boxes. It's going to be draft round is a big box with the position groups within those boxes. And the position groups are going to be sized by N, which is the count of players drafted within that round specific to that position group.
So yeah, there's additional arguments in there too. You're able to define the title of the plot, so that's output. Then you're able to define various things like at the very end there, you define the positions of the labels.
Yeah.
And so Courtney also did that.
Yeah. I've just commented it out so you can see at each step what elements of the plot these arguments are changing.
Mm-hmm.
So we'll go ahead and run it. We're gonna see we get the same little issue here with the viewer window.
Yeah.
I know. So,
it's not showing up
so
right.
what I did was you could run all of this line here, and it'll give you something like a PNG file. So I just write this out to a PNG file, which is right there.
There you go.
So I just save that to my working directory, and I can open that up. So here we have, obviously, the free agents. That's the largest because we know that through the 7 rounds, there's roughly only 32 picks. There will be some compensatory picks in there, but the free agents, there will be multiple players. Every team is going to call in multiple players to fill out their roster for rookie training camp and things like that. Here's our first round. So again, these kinds of plots are really useful in the exploratory data analysis phase where you might try and ask some questions. For example, round 2 here looked to be pretty heavy on defensive backs. Round 1 here is a really interesting one because it looks really heavy on defensive linemen and defensive ends. And as I recall from 2019, that was a pretty defensive end, defensive line, edge rusher, pass rusher type heavy draft. So we might look at that and sit with the domain experts and ask about what that is or why that might be. We can go back here and really easily we can filter out those players from the original data set. So I pass the original data set, Combine 2019, and I pipe in a filter function. I want only round 1, and I want only if their position group was called defensive line or defensive end. When I run that, we'll see, we had Josh Allen, Nick Bosa, Brian Burns. Nick Bosa was pretty good. Brian Burns.
Pretty good years.
Yeah, pretty good year for Clemson. So you see 1, 2, 3 Clemson Tigers on the defensive line all went in the first round, which is pretty incredible. Yeah.
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 The fact that one school can get so many people off in the first round, in the defensive end and defensive D-line position, that just a lot of people went from there.
Well, not only that, they lost all those guys and they still went back to the championship game again. So that's they've got quite a stable of players running through there. It seems like. But yeah, that's a little bit on the tree function.
Mm-hmm. Well, thank you for joining us. I hope that you learned something from this, and we look forward to doing this again in the future. If you have any comments or questions, concerns, please reach out to us and leave a comment, and we will try to address those. So thank you again for listening, and keep it tidy.